find an angle between 0 and 2 pi that is coterminal to this. So let's first look at it visually. Let's first draw this. So to draw that, I'm going to start with, always right here to start with, and I'm going negative pi over 3, or negative a third of a half circle. So a third of a half circle, if we're going down, that's a sixth. So 2/6 is a third. So that right there would be a negative 1/3 of a half circle, or pi. That's negative pi over 3. Now, what I want is, I want a coterminal to that between 0 and 2 pi. So visually speaking, aren't we just asking for this wraparound? That's all we're asking for in the visual way of looking at it. So let's go and wrap around this way, and what would that be? Well, isn't this going to be pi, or half a circle? So that's 1 pi plus a sixth, a sixth, a sixth, and a sixth. You see how we have 4/6 more. So 4/6 reduced is 2/3. So what I have for the green is I have 1 and 2/3. Now we don't write it as 1 and 2/3. We change that to 5/3. But isn't it 5/3 of pi? Because pi is a half circle. So this is 5 pi over 3 for this here, because you have 1 and 2/3 the way around the bottom. Again, half circle, we're going by half circles, not full circles. So that is an answer. Boom. But let's do it as if we didn't have a picture to draw and we want to do it by numbers. With numbers, what we're going to do is we're going to take negative pi over 3, and I want to revolve it. Do I want to add a circle or subtract? What I want to do is I want to add a full revolution. And a full revolution in terms of radians is 2 pi. So I want to add 2 pi to this. If I subtract 2 pi, I won't get a number between 0 and 2 pi. If I subtract, I'll get more negative. So I have to take this and subtract. Now some of you are going, oh crud, I have a fraction plus a whole number. Oh no, it's easier than you think. Let's practice. How do we combine these? And that should give us this answer. Well, what we do is, I'm going to put a 1 underneath here, and then I'm going to multiply top and bottom something, so I get a denominator of 3. Because don't I want that denominator so we can add? So if I want a denominator of 3, can I just multiply top and bottom by 3? So don't I have negative pi plus, negative pi over 3, plus, well, what's 2 times 3? Isn't that 6 pi on top? Over 3? 2 times 3 is 6, over 3 times 1. Now, let's stop and think. Is 6 divided by 3 equal to 2? Is that correct? Does 6/3 equal 2? Yes. Okay, we're on the right track. Now, since the bottoms are the same, can't we just add the tops? And when I add the tops, watch what happens. Don't we get negative 1 pi plus 6 pi? Isn't that over 3? Again, when you add fractions, don't you add the tops, leave the bottom. So does that give us 5 pi over 3? The answer we were looking for. Yeah. So does it matter which way? Do these two give us 5 pi over 3? Yes, they match. We are doing it either way. Whatever works best for you, it's best to know both. Find 2 angles that are coterminal with 7 pi over 2. Now 7 pi over 2, that's kind of big. So let's draw that to start with. But before I even start with that, 7 divided by 2, let's think about that as a mixed number. Are you okay that 2 goes into 7 3 times with 1 left over? All right, so I'm going to start here, and I'm going to have, that's 3.5 pi's. Now, a lot of people make a mistake, and what they do is they go, okay, that's 1, 2, 3. No. Isn't 1 pi halfway? So you got to be careful about that. That's a common mistake. So isn't this right here 1 pi? So wouldn't this right here be 2 pi? I'm going to change colors. So won't this right here be 3 pi? Because we have 3, and we need a half more. So a half, wouldn't a half go right to there? So do we now have our terminal spot? That right there is 7 pi over 2. Quite a few loop-de-loops. Now, I want two coterminal angles. I want two angles that terminate there. So one of them, well, could I visually just say it's that right there? So let me kind of think that one through. What would this right here be if I just went that direction? Well, can you see that's a half of a pi in the negative direction? Isn't that half a circle in the negative direction? And then also, well, isn't this blue part also a coterminal angle? Isn't that blue part the second part of the whole loop-de-loop? So that blue part, let's do that one. Well, wouldn't that blue part be 1.5 or 1.5? Isn't that 3 pi over 2? Again, that's 1 pi and a half. So aren't these two coterminal angles? Are we done? Yeah. But don't we also want to practice it without drawing it? So let me do the non-drawing way. We were done. There's our two answers. There are two possibilities. Let's do it another way, though. What I'm going to do here is I'm going to take 7 pi divided by 2, and I'm going to first add 2 pi. So to do that, aren't you going to put a 1 underneath, and I'm going to multiply top and bottom by 2, because I want to get a common denominator. When I do that, I get 7 pi over 2 plus 4 pi over 2, which when I reduce that, wait a second, don't you get 11 pi over 2? Wait, that's not one of my answers. But if I were to take this and wrap around one more time, would that be 11 pi over 2? Oh yeah, it would be. So is this okay to add to our two answers? Is it another possibility? Yeah. It's just an extra wraparound. That's fine. Okay. So we got one. Did it a different way. All right. Since we added 2 pi, could we also subtract 2 pi for an easy alternate? So I'm going to take 7 pi divided by 2, and I'm going to subtract 2 pi. Now that we figured it out, isn't 2 pi 4 pi over 2? So is it okay if I put 4 pi over 2 instead of 2 pi this time? Since last time I figured that out. And then if I subtract this, don't we leave the tops? So won't that give us 3 pi on top, and the 2 stays on the bottom? And now does that one, oh, that one matches. Okay, cool. So these are two, this one matches, and this one didn't even come up. Well, could I get this? Yeah. If I took and subtracted 2 pi again, would I get that answer? Yeah. But why? I actually have 3 answers now. Okay, great. I have 3 answers. Okay. But we did it 2 different ways.